At the farthest edge of the cosmos, light that has traveled for billions of years reaches our instruments as a faint whisper from the dawn of time. In this silent expanse, the James Webb Space Telescope has revealed a new mystery: tiny, distant galaxies glowing as faint red embers against the black tapestry of space. Astronomers have named them little red dots, enigmatic objects whose very existence is reshaping our understanding of how the first galaxies emerged in the early universe. These little red dots, or LRDs, were invisible to every telescope before JWST. For generations, astronomers peered into the darkness, believing that the first galaxies were sprawling, blue, and bursting with the energy of newborn stars. Instead, JWST's powerful infrared eyes have revealed something far more perplexing: galaxies so compact and so red they challenge everything we thought we knew about cosmic dawn. Let's take a closer look at what makes these galactic specks so extraordinary. Each little red dot is a miniature powerhouse, packing an astonishing number of stars into a volume far smaller than typical galaxies. Picture a swarm of ancient suns compressed into a region no wider than a fraction of our own Milky Way. The sheer density of stars is mind-boggling, raising immediate questions. How did so many stars end up in such a small space? Are these truly ancient stellar cities, or could something else, something even more exotic, be hiding at their cores? At first glance, LRDs might seem unremarkable, just faint smudges against the cosmic background. But, as astronomer Fabio Pacucci explains, their very existence is a fundamental mystery. If these galaxies contain only stars, their central densities are so extreme they border on the impossible. If they harbor black holes, those black holes would have to be far more massive than anything we'd expect for such tiny galaxies. The puzzle is as tantalizing as it is profound. The true breakthrough comes from a new theory that links these little red dots to the invisible scaffolding of the universe: dark matter halos. Every galaxy forms within a halo of dark matter, a mysterious, unseen substance that makes up most of the mass in the cosmos. But not all halos are created equal. Some spin rapidly, flinging material outward and allowing galaxies to spread out, while others rotate with a languid, almost lazy pace. It's these low-spin halos that may be the silent architects behind the little red dots. In a typical dark matter halo, angular momentum, the cosmic equivalent of a figure skater's spin, dictates how material is distributed. High-spin halos give rise to sprawling spiral galaxies, their arms flung wide by the force of rotation. But in the case of LRDs, the halos are almost eerily still. With so little spin, gravity wins the battle, pulling gas and dust directly toward the center. This leads to an extraordinary concentration of matter, a cosmic pressure cooker in which stars can ignite in quick succession, or where a black hole seed can rapidly gorge itself on inflowing gas. The implications are staggering. In these low-spin environments, black holes could form much faster and grow much larger than previously thought possible. Imagine a primordial black hole, born in the very first generations after the Big Bang, gobbling up matter at a breakneck pace, becoming a supermassive giant while the rest of the universe is still in its cosmic infancy. These little red dots may be the first cradles of such supermassive black holes, objects that would later anchor entire galaxies like our own. But why are these galaxies so distinctly red in color? The answer lies in their age and their composition. Unlike the hot blue star-forming regions we see in closer, younger galaxies, the light from LRDs is stretched by the vast distances it travels, shifting into the infrared. JWST is uniquely equipped to detect this ancient reddened light, peering further back in time than any previous observatory. The red color of these dots is both a marker of their distance and a clue to their ancient origins. Astronomers were astonished not only by the color and compactness of these galaxies, but by their sheer abundance. JWST's deep field images are littered with these mysterious objects, each one a potential window into the conditions of the early universe. The little red dots seem to defy the standard models of galaxy formation, which predicted that the earliest galaxies would form gradually, growing larger and brighter as they accumulated more stars. Instead, these galaxies appear fully formed, dense, and remarkably mature, like cosmic time capsules from an era when the first structures were just beginning to take shape. At the heart of the little red dot mystery is the question of their true nature. Are we seeing the first stellar clusters packed so tightly that their stars are nearly shoulder to shoulder? Or are we witnessing the birthplaces of the universe's first black holes, the seeds that would eventually become the monsters lurking at the centers of modern galaxies? The evidence is mounting that supermassive black holes could indeed be hiding within these compact galaxies, their gravitational pull shaping the fate of all the matter around them. The theory presented by Piccucci and Avi Loeb suggests that the unique properties of low-spin dark matter halos are the key. By funneling material inward, these halos create the perfect environment for rapid black hole growth or for stars to collapse into hyperdense clusters. This central concentration of mass could explain both the tiny size and the extreme density of the little red dots, and may finally reveal how the first black holes formed, not as a gradual process, but in a sudden dramatic burst at the dawn of cosmic time. For the first time, we may be glimpsing the missing link in the cosmic story, the moment when dark matter, gas, and gravity conspired to create the first massive black holes, long before the universe settled into its current, ordered state. The discovery of the little red dots is more than just a curiosity. It's a window into the most mysterious and violent chapter of our universe's history, a chapter that has remained hidden until now. The James Webb Space Telescope's discovery of the little red dots has completely upended our understanding of the early universe. These galaxies, so faint and distant that they evaded even the sharp gaze of the Hubble Space Telescope, now offer a tantalizing glimpse into cosmic epochs just a few 100 million years after the Big Bang. Their crimson color is a result of the immense redshift caused by the universe's rapid expansion. Their light stretched and cooled as it traveled for over 13 billion years to reach us. Yet, the color alone is not what makes the little red dots truly remarkable. It's their compactness, their density, and their unexpected maturity. Instead of sprawling clouds of newborn stars, astronomers found tightly packed objects, each just a fraction the size of our Milky Way, but with a mass that rivals much larger galaxies. It's as if entire galactic cities were squeezed into the space of a small town. To explain these cosmic oddities, astrophysicists turned to the invisible scaffolding of the cosmos, dark matter halos. These halos, made up of mysterious particles that neither emit nor absorb light, are the silent architects of galaxy formation. They provide the gravitational wells that gather ordinary matter, hydrogen, helium, dust, and gas, allowing it to cool and collapse into stars and galaxies. But not all dark matter halos are created equal. Some spin quickly, spreading their mass more broadly and giving rise to sprawling disk-like galaxies. Others, like those linked to the little red dots, spin much more slowly. This low spin means that matter collapses straight into the heart of the halo, creating an incredibly dense, compact core. According to the latest research, this is the perfect environment for something extraordinary to happen. In these low-spin halos, the rapid concentration of mass dramatically increases the chances for the formation of a supermassive black hole. Normally, the creation of such enormous black holes is a puzzle. How could they grow so big, so fast, in the brief window after the Big Bang? The little red dots may hold the answer. In their centers, the gravitational pressure would be so intense that clouds of gas could collapse directly into a black hole, bypassing the slower process of star birth and death. Alternatively, a single massive star could form and die almost immediately, seeding the center with a black hole that would then gorge itself on the dense material all around it, growing at a breathtaking pace. This theory, proposed by researchers Fabio Pacucci and Avi Loeb, suggests that the little red dots are either the densest star clusters ever observed, or more likely, the cradles of the first supermassive black holes. In either case, they represent a missing link, a bridge between the first simple structures of the cosmos and the complex galaxies that would follow. But the mystery deepens. If these galaxies are primarily made of stars, their densities defy what we thought was possible. Theoretical models struggle to explain how so many stars could form and crowd together without tearing themselves apart through gravitational interactions. On the other hand, if the central mass is dominated by a black hole, it would have to be astonishingly massive for such a tiny galaxy, a scenario never before observed. Galaxy, a scenario never before observed. The implications ripple far beyond the little red dots themselves. If supermassive black holes can form so early in such small and dense environments, it transforms our understanding of how black holes and galaxies co-evolve. Rather than forming in large, well-ordered galaxies, black holes may have appeared first, shaping their host galaxies from the inside out. This would fundamentally alter the timeline of cosmic evolution and force astronomers to rewrite the earliest chapters of the universe's history. What makes the Webb telescope so essential in this quest is its unprecedented sensitivity to infrared light. Unlike visible light, which is easily scattered or absorbed by dust and gas, infrared light can pierce these cosmic veils, revealing objects hidden from all previous observatories. Webb is not just peering farther than any telescope before, it's opening a window into a time when the universe was a wild, tumultuous place, filled with processes that would set the stage for everything to come. By targeting the little red dots, scientists are effectively conducting a cosmic archaeology, digging back through layers of time to uncover how the first structures formed and how the seeds of cosmic order were planted. The detailed spectra Webb captures allow researchers to analyze the chemical fingerprints of these galaxies, revealing whether they are dominated by stars, black holes, or something even stranger. Already, clues are emerging. Some little red dots show signs of intense energy at their cores, radiation that could only be explained by the presence of an actively feeding black hole. Others exhibit spectral lines hinting at rapid star formation or highly compact star clusters. Each new observation adds another piece to the puzzle, guiding astronomers as they refine their models. And as Webb continues to scan the sky, the number of known little red dots grows. Each one is a beacon from the ancient cosmos, a record of the universe's earliest, most violent experiments in galaxy building. They are a testament to the power of gravity, dark matter, and the relentless drive of the cosmos to build complexity from chaos. The discovery of LRDs marks not just a technical triumph, but a profound leap in cosmic understanding. For the first time, we are seeing evidence that the earliest black holes could have formed in environments unlike anything seen in the modern universe, compact, red, and fiercely energetic. These findings are poised to answer one of astronomy's oldest questions. How did the first supermassive black holes arise, and what role did they play in sculpting the universe we see today? But the story doesn't end here. The search for answers is only beginning, as scientists push the boundaries of observation and theory, determined to unravel the secrets hidden in these distant, ancient dots of light. The next steps will require not only the continued power of the James Webb Space Telescope, but also the ingenuity of astronomers and the promise of future missions set to probe the universe's deepest mysteries. The implications of these little red dots reach far beyond our current understanding of the early universe. As scientists continue to analyze the data pouring in from JWST, each new observation peels back another layer of cosmic history. The revelation that these compact galaxies may be the cradles of the very first supermassive black holes is shaking up long-held theories about how such titanic objects formed and evolved. For decades, astronomers puzzled over how supermassive black holes, some weighing billions of times more than our Sun, could have existed so soon after the Big Bang. Traditional models struggled to explain how enough matter could collapse and accrete in such a short cosmic time span. But now, the discovery of LRDs in low-spin dark matter halos provides a tantalizing solution. These unique environments, dense and centrally concentrated, may have served as cosmic nurseries where black holes could form rapidly and grow to enormous sizes, all before the first large galaxies had even taken shape. This connection between dark matter halos and the birth of black holes is a cutting-edge frontier in astrophysics. Dark matter, which makes up roughly 85% of the universe's mass, remains invisible to our instruments, detectable only through its gravitational influence. The idea that its properties, such as spin, could dictate the structure and destiny of entire galaxies, and even the formation of black holes, opens up a new realm of questions. Are LRDs a rare cosmic phenomenon, or did they represent a common pathway for galaxy and black hole formation in the early universe? How many other unseen structures shaped by dark matter still await discovery in the cosmic deep? The continued study of LRDs will require not only more observations from JWST, but also the combined efforts of future observatories and innovative simulations. Missions like the Nancy Grace Roman Space Telescope and the upcoming European Extremely Large Telescope promise to sharpen our view of the distant cosmos, allowing scientists to probe the environments around these compact galaxies in unprecedented detail. By capturing the faintest whispers of starlight and tracking the gravitational fingerprints of black holes, researchers hope to piece together the evolutionary history of the earliest cosmic structures. But the mysteries don't end with LRDs. Each discovery made by JWST seems to raise new questions. For example, the telescope's detection of massive starless planets cradling potential moon disks challenges our understanding of how planetary systems form. And the recent finding of a previously hidden moon nestled within Uranus's rings demonstrates the power of next-generation telescopes to reveal secrets close to home as well as across the universe. Together, these findings are reshaping the narrative of cosmic evolution. They remind us that the universe is far more dynamic and surprising than we ever imagined. The early universe was not a quiet, gradual unfolding, but a turbulent era filled with rapid star formation, the birth of black holes, and the relentless sculpting of matter by invisible dark halos. Each new dataset, each faint flicker of light captured from billions of years ago, brings us closer to understanding how everything we see today, from stars and galaxies to planets and moons, came to be. As we look deeper into the cosmos, we are also looking further back in time, unraveling the story of our own cosmic origins. The little red dots, once invisible and unknown, are now at the center of a new chapter in astronomy. They are beacons from an era when the universe was still young, when the seeds of galaxies and black holes were just beginning to take root. Their discovery is a testament to the ingenuity of scientists and the power of human curiosity. The journey of exploration is just beginning. With every new observation, the universe grows more intricate, challenging us to ask new questions and build new models. The next breakthrough may be just beyond the reach of our current instruments, waiting for the next generation of explorers to find. If you're as fascinated as we are by the mysteries of the cosmos, make sure to like this video and subscribe for more content like this. The universe is vast and full of secrets, and together we'll continue to explore its wonders. Explore its wonders.